Developers are increasingly being tapped to not only write secure code but also build up container images. This adds the complexity of navigating the minefield of operating system level vulnerabilities, a task that historically was handled by the other teams. Snyk container vulnerability scanning empowers developers with tools that can be implemented at all stages in the software development lifecycle pipeline, including most importantly their workstations. Hey, how you doing? This is Saim Safdur and you are listening to the CloudNative.fm podcast. In this episode, we dive into getting started with container security with Snyk with my guest Matt Jarvis. But first, let me introduce my guest. Matt Jarvis is a senior developer advocate at Snyk. Matt has spent more than 15 years building products and services around open source software, on averaging from embedded devices to large-scale distributed systems. Most recently, he has been focused on the open cloud infrastructure space and in emerging patterns for cloud-native applications. Matt is a regular speaker at conferences across the world, including Open Infrastructure Summit, FOSDM, and All Things Open. A past winner of the OpenStack Outstanding Community Contributor Award, and in 2021 was named one of the top 100 influencers in open technologies in the UK. Matt is also a board director of OpenUK and the founder of Cloud Native Manchester and Cloud Natives UK. Want to see what he is up to? Follow Matt Jarvis on Twitter at mattj_io. And let's go ahead and say hi to Matt Jarvis and get it over to the interview. Everyone, and this is your co-host for the CloudNative.fm podcast, and my name is Saim Safdur, and I'm really excited today because one of my guests is from the container security, and a lot of the folks are interested in learning what the container security is, what are the core primitives in order to run, in order to take interest of the security kind of things. So I'll finally met the person and hopefully can answer all these questions in here in this CloudNative.fm podcast. Matt Jarvis, he works as a senior developer advocate at Snyk. How are you, Matt? And can you introduce yourself to my audience, where you live and where you work right now, and what are your current role in Snyk?
Yeah, sure. Thank you for having me. So I'm Matt Jarvis. I'm a container security and about Snyk and about how we work. I live in a place called the Lake District in the north of England, and I would usually spend a lot of my time on planes and in hotels all over the world talking at conferences. But obviously, for the last year or so with COVID, I have been mainly sat in these four walls that you see in front of you.
Yes, definitely. I think everybody is containerized because of the COVID and coronavirus situation.
Indeed.
But before we jump into the container security, so I kind of interesting to know what's this developer advocate's role is, and what are the idea behind what Snyk stand for, and how did you join the Snyk, and what's your prior to Snyk's container security, how your life goes with these kind of roles?
Yeah, sure. So, so developer advocates are really, I always think of them as the conduit between a the user community. Our role is to engage with developers who are using, in this case, Snyk, but in the general sense, whatever piece of technology or product that you're working on. So developer advocates spend a lot of their time creating content, perhaps blogs, perhaps videos. We spend a lot of time doing conference talks, doing podcasts like this, and generally kind of engaging with folks in the community. I've been in developer advocacy, developer relations for about the last 5 or 6 years. Prior to Snyk, I was at a company called Mesosphere, so working on Apache Mesos and on Kubernetes. And before that, I have worn a lot of different hats in my career. I've worked in research and development for big companies like IBM. I've also worked at startups. I've been a CTO of a cloud startup. And so I think one of the things that you need when you get into developer advocacy is that you need to explain the context of things. And, so in a way, having had some life experience and lots of different roles in technology before this, it gives you the ability to hopefully to be able to describe the context of the things that you're working on. And so, it's important to know what went before and kind of what's coming up next in technology. And so, having had a pretty varied career, it kind of helps you give that context. I've been using open source software for probably over 25 years. And so, one of the descriptions I give to people of what my career has been is building cool stuff using open source software and using Linux. When I discovered Linux in the mid 1990s, work is I guess at the heart of it.
Yeah, definitely. I think that right now companies need this kind of developer advocacy because things are in the cloud native landscape are evolved really rapidly. And a lot of the toolings I think the people are developing is somehow integrate with some other tools. So every time you see a Kubernetes now integrate with the clouds, with the IoTs, with any infrastructures. So you need an advocacy role in your current team. So describe what your tool is and how well it is integrated to other tools, and how and also on part of this, I think having a community on board is another thing. I think that's developer advocacy I think is a very hot role right now. And some of the people say that we is very scary role because we are in front of the people, we criticize them. So some days, some people criticize. Some days they are really excited about what the work you are currently do. But I think the developer advocacy role is really a great role, and I really had great to have you on the podcast because I think you are the person who can answer these kind of the container security question for me. So let's start with the first topic of the containers. So I think that whenever the containers evolve and they have come up, so everybody take it as a virtual operating system as containers are. So I think if a virtual operating system mean you have to scale this virtual operating system. So everybody cannot give a root access to the containers. So underlying, they cannot use the kernel host operating system. So let's start from the virtual operating system concepts and let's start introducing what the containers are and how it's got bloated and everybody talking about and how it's got most popular within a very few years.
Yeah, absolutely. I mean, I think that's one of the key differentiators between virtual machines and a container is that the virtual machines have their own copy of the operating system, including the operating system kernel. And so a virtual machine is running on top of a hypervisor. And so you have separation between virtual machines running on the same machine. You know, they've all got their own independent kernel. A container really is a construct, if you like, that's created by the operating system kernel. So all containers share the same kernel underneath, and containers are really just a process, and they are originally, you know, what we describe mostly as containers now is we're talking about Linux containers. And so there's a set of functions give some kind of separation between processes. You know, there have been things that have existed like containers for quite a long time. We can put them in the same kind of category as things like jails in Unix or zones in Solaris. And just a process that is containerized by the host operating system kernel. So it stops other things from accessing the same network namespace or the same storage, for example.
Yes, definitely. And I think because I think the namespaces and the control groups are really the containers. We are talking about how to can isolate the processes and how to request and set the quotas, and that's essentially is containers. If you talk about it a little deeply, the namespaces and control groups.
Exactly. I mean, yeah, and both of those are functions of the kernel. So C groups and namespaces is really how the kernel creates this container, this kind of thing. Get slightly confused about is how strong that boundary is. You know, it's not a strong boundary in the same sense as a virtual machine is, because, you know, when you look at the host process table, all the containers that are running on that host are there running as processes on that single host.
Yes, definitely. And I think a lot of the confusion is around in the cloud native ecosystem, because I think we now know that the 4 C's are the cloud native securities. You start from the cloud, and from the cluster, you have the code, and then you have the containers. So people are thinking about where should we start thinking about the security. Either thinking about how to securely run the code, how to securely run the containers, and might be within a pod, there are many containers because Kubernetes had this construct called pod. So you have to securely how to secure your pod, multiple container, and inside it. So what are the first parameters, or what are the first steps you need to cater for in order to understand the security in a highly effective manner in terms of container security?
Yeah, so I mean, I think there's 2 things. You know, if we step back a little bit and look at what's really changed over the last say 5 or 10 years in terms of how we treat security. You know, and the first thing is that developers are responsible for a lot more of the infrastructure, right? So, you know, when even in the virtual machine era, you know, developer teams were probably just responsible for the bit that was their application. Someone else managed the virtual machines, someone else managed the virtual network, someone else managed the virtual storage. And as we've moved into the cloud native world, you know, it's the application and the container that we deploy in, application never gets deployed without the container. And so, and often the same team is developing the container image as is developing the application. So now we've got the same team having responsibility for the application and the container image. And they're probably responsible for the Kubernetes configuration. So, you know, in terms of the amount that developers are responsible for is really increased dramatically, you know. And then the second thing is that this speed that we deploy things has gone up dramatically. You know, when I first started in this industry, the standard kind of operating practice for most IT teams was, let's try to change as little as possible, right? Because we just stay the same and then we know nothing's changed. But now, the ability to deploy software really, really rapidly, new versions, new features, is a key differentiator for companies to succeed, right? The faster that you can deploy your software, the faster that you can get new features out to your customers. That's what's going to define whether somebody else takes your market. And so you've got these two things, these fundamental things about speed, and now we've got developers owning loads of the stack, including bits of infrastructure and all the rest of it. And so what we really need to consider is that we need to push security responsibility over to those teams. We used to have security right at the end of the process, and now we need it right at the start. We need developers to be able to understand the security and have tools that help them to make choices about security. So having said that, in terms of our cloud native delivery kind of pipelines, what we really need to do is to have security at all of those stages, right? We need to be able to check our security right when we're developing our container images. Then we need to check stuff in our source code repositories. We need to test our container images in our container registries. We need to test in our build systems, and then we need to test in Kubernetes. So all the way through our deployment pipelines. And, that's tricky for most people to get their heads around, right? But, automation's the key to this, that we need to build this automated scanning in all the time. But then the other important piece that we need to consider really is understanding where our security issues can come from. So on the one hand, we've got our application, right? And our applications, if we've created that application, most applications these days are a very small amount of code that we wrote and lots of third-party open source modules, right? If you write a Java app, you write a Go app, you're going to be bringing in all these packages, modules and that's great. It means you don't reinvent the wheel all the time, but those things have vulnerabilities in them. So you need to have tools that can scan those open source modules. And then we've got our packaging, so our container images. And, we can get container images from lots of different places, from Docker Hub, from any of the public registries out there. And, there are lots of those things that are out there that you can just pull down and use will have lots of security vulnerabilities in them. So that's the second place that we need to be looking. And then the third place that we need to be looking is in our infrastructure as code. So, in things like our Kubernetes YAML, our Terraform, any place where we're defining infrastructure. And those things can, if we take Kubernetes, for example, Kubernetes is actually extremely insecure by default, because Kubernetes gives you a huge amount of flexibility. So you need to understand which things you need to control. And so, things like, if I don't provide resource limits, that means that pod, if somebody exploits that pod can take as much resource as it wants until the host that it's running on, the kubelet, runs out of resources. So you can have denial of service attacks in that way if you don't define how much resources your pod can use. And running containers as root. If as soon as you run a container as root, if that container is exploited, then an attacker can expand the blast radius of that exploit because they've got root within that container. So they can, try to attack other pods. They can do all sorts of things. So yeah, there's quite a lot of things to consider there when we look at security. But really, it's about looking at all of these things all the way through our deployment pipeline, right from giving developers access to tools within their IDE, within their CLI, like Snyk does, to scan code as you're writing it, through to integrating into your container registries to scan your container images, and integrating into Kubernetes.
Yes, definitely. I think the whole point of the match discussion is you start from the development machine, because I think essentially the layers of Docker images are built from the layers up. And these layered images actually the blueprint of the containers that are going to be deployed in the production environment. So you need to in front of your developer so that they can run how much they're vulnerable to the attacks. So I think the Snyk and Docker provide a collaboration in this first phase. So the developer can run Docker scan command and they can understand what are the vulnerabilities they can get if in this let's say the image of Alpine image or Fedora image or these kind of Linux images. And on top of that, you run the code inside the layered based structure that the Docker follow. And I think that it's essentially is a development flow. You start from the developer machine, go to the staging and production, to the QA, and these are the tools you need to have. But I think you have to start from the development machine, the code, and then you have to run. There are two types of, I think, then you have the imaging scanning, you have to be available there. And then you have the Kubernetes cluster that you need to secure. So I think there's so many moving parts into that. So I think
absolutely.
And the next question, I think that's really interesting for me. I think there are two constructs of building the images. One, you have, let's say, the operating system that has the kernel inside of it, but in the another image, you don't have a kernel inside of it, but is utilizing the host kernel. So what are the two? These are the two, I think, the practices that people uses. They have a base image, but that base images also contain the kernel as well. So without utilizing the kernel underneath the host, they're utilizing the base image layer kernels. And some of the people are using the images that utilizes the host kernel in making the call to the API. So what are these two practices are, and which one is going to be beneficial for the people if they want to adopt it?
So in terms of containers will all use the host kernel. That's the fundamental difference between a container and a virtual machine. If you have a running kernel inside a construct, that's effectively a virtual machine. It would need to be running on a hypervisor then. There are things like Kata containers and gvisor and things like this, which sort of sit in between what Docker containers are and a virtual machine. So they're very lightweight virtual machines, effectively. And you can launch those kinds of containers through Kubernetes. You have integration into Runc for those types of technologies. And they're not very widely used at the minute, but it is a model for saying, well, when I deploy this kind of workload, I want more security. And so if I deploy it in a Kata container or in gvisor or in that kind of technology, and then I'm going to get something that's more secure than my Docker container. And you can have those runtimes coexist within the same Kubernetes cluster. It's not a pattern that I've seen very often in the real world, but it's certainly the kind of technology that I think we're going to see more of, because you really want to have a lot of different options about how you deploy different workloads. I may have one particular class of application that doesn't need the same level of security as another, and so having access to different runtimes within the same Kubernetes cluster gives you those options at deployment time.
Yes, definitely. And let's start from the workflow that we previously discussed. So I think in the developer machine, we have a Snyk and Docker collaboration. So you can draw some points on as well. So how the Snyk and Docker collaborate in the development environment. So give you the scanning and the vulnerabilities process. So let's start from there.
Yeah, so we built together with our friends at Docker, we built an integration directly into the Docker CLI. You can use the Snyk CLI for exactly the same purposes, but really the approach, what we call developer first security, is about making security available to developers in as frictionless way as possible. So, giving developers the right tools where they're actually working. So if you're building an image using Docker, using the Docker CLI, you might be doing Docker build, editing your Docker file, building using Docker build, and now you can just do Docker scan, and that's going to scan your Docker image right there in your local Docker environment before that's even left your machine. So while you're building and developing your container images, you can scan them directly in your local machine, and so you get that visibility straight away of like, does this particular image have security vulnerabilities in it? You can, like I said, you can do exactly the same with the Snyk CLI, but having that built into Docker means, that security information is just available to more people. You don't need to install the Snyk CLI to have access to that security vulnerability information.
Yes, definitely. I think that's the first part of the security. You have the trust what you build in your laptop. How much how much you trust your code. I think that's number one step. And next step, you move the image into the container registry. So what the next step in there, in the container registry, how to secure, what the Snyk provides there, and what are the best practices around that by hosting your container or your images into the container repositories.
Yeah, so I mean, so Snyk integrates actually with a whole range of different registries. Most of them that are out there, from obviously Docker Hub, but also the registries from Amazon, from Google. But it's just very good practice to integrate security scanning into your registry. Let's imagine that you built a Docker image, 2 weeks ago, and it didn't have any vulnerabilities in it, or didn't have any severe vulnerabilities in it, and you push it to your registry, you start using it. Well, new vulnerabilities are discovered all the time. So if you're just relying on that first scan when you built it, you're never going to catch the things that are coming over time. And most security tools like Snyk will scan things on a regular basis, sort of monitoring scans. So you can get information on things that are happening. By default, we scan every 24 hours. And so you can get an indication from your registry about whether your images might have new vulnerabilities in them that they didn't have when you built them.
Yes, definitely. I think that's really important because developers are using, as you mentioned, third-party libraries, and underneath, let's say they have the images that is built upon the node layer. So node layer is always changing all the time. This has some new bugs, new fixes, new releases all the time. So you have to know what's happening when you're pushing the image into the registry. So Snyk has this integration. It's give to the real data how well is your container is now at this moment of time. It's how much vulnerable to the attacks. So that's number two part of it. And now I think in the next step, someone pushing the container images and deploy that container into, let's say, the Docker Compose and then the Docker in the Kubernetes cluster. So what are the integration of securities there? What are the things you need to encounter in deploying these images, container images and apps into the Docker Swarm, Kubernetes, or other orchestration platform to secure?
Yeah, so I mean, typically what you want to be looking at there is scanning images that are at deployment time, but also scanning things on an ongoing basis within your cluster for exactly the same reasons as we talked about with registries, right? Because things can change. And, if you have container images that are long running, that have been running in your cluster for a long time without changing, then, you're likely to have picked up, potentially picked up new vulnerabilities, particularly in your base image. Your base image is going to contain a lot of software in it, probably, and so you want to really be catching things like that over time. I think there are another set of considerations about production that some of which Snyk play into, and some of which other security tools do. You can look at things like admission control is something that's a really growing space. If you look at things like Open Policy Agent, where when we try to deploy to our Kubernetes cluster, if our Kubernetes configuration is not correct for that container, as defined in our policy. So, for example, we might say in our policy, we're not going to allow anyone to run containers as root. And so what Open Policy Agent together with Gatekeeper will do is to say, to actually refuse deployment of that container because it doesn't have the correct security settings. So admission control is an important point because that's really the gate on things getting into your cluster. And then, the other place to consider is about runtime security. And runtime security is really about things changing once they're up and running. We're no longer thinking maybe about the container image itself or about your piece of code, but more about has my code been exploited? And here in this space, we can look at things like Falco, where we're looking at patterns of behavior. So, if I have an application that under normal practice should only be doing certain things, only accessing certain files, only opening certain network connections, if all of a sudden that application starts to do things that are unusual, then you can detect that stuff with tools like Falco.
Yes, definitely. I think the next point I think we mentioned is that when you have the images that is already scarce, you need a team to understand how well is happening in there. You need some kind of policies that the container is not utilizing the host operating system in a bad way. So they can put out the file and so everybody can use that as a run as a root. If they have some kind of run as a root, they can do anything they want it to do.
Yeah, exactly.
And we have to protect that. And in order to protect that, you have some kind of policies there. And one of those policies are OPA and Gatekeeper, and you need another tool for that. And when the container is running in the production environment, I think you need a runtime security because all the times the kernel call is happening, the sys call is happening.
Yeah.
You have to ensure the right sys calls have to be happening, and unprivileged sys call is not going to be happen there because in the production, if somebody can gain access as the root of the container and are utilizing the operating system, then you can do whole kind of vulnerable things to the cluster. So these are the two things. So before I let you go, we have dive in a very small amount of time. I think we cover a lot of great topic in the container security. But I think before I let you go, the number one question is people came up their mind. So do in a future we able to see the one tool that can do a lot of things? Let's say we have a Snyk tool that can do the integration of the vulnerabilities. They can scan the images. And we have another tool for the open policy as an agent that can remedies the policies. And then we have another tool that run that checking the runtime security of the container. But people are really interesting to know if in the future they can see a one tool and they can do everything on behalf of them. Do you see the container ecosystem is going in that way, or we still need some kind of integration with these other tools?
I mean, I think it's an interesting point. I'd love to be able to say that Snyk are going to cover all of these spaces, but you kind of have to focus on the bits you're good at. I mean, certainly what we are building at Snyk is a cloud native security platform so that you do have information about your code, your open source modules, your software licenses, your container images, your runtime all in one place. Because you can start to, connect these data sources together in interesting ways to provide further insights into what's going on in your cluster. Do I think there'll ever be, one magic tool that will do absolutely everything for you? I think probably not, because so there are things that are very good at what they do. Falco is very good at runtime syscall detection. In a sense, this is one of the things of cloud native in general, isn't it? Our ecosystem is broad and deep. And, lots of people say, well, why have we got all these projects? Why, can we not just have one project that does everything? But I think it's one of the great things about the cloud native ecosystem is choice. You do have lots of different choices about how you do things. But I guess it does also make things complicated in terms of understanding which are the pieces that you should use, to build your cloud native environments.
Yes, definitely. I think that where you already point at child, because everybody is good at certain things, and you need some kind of knowledge for the other people's, other community members. They've done a very super amount of effort in building those projects. So you need some kind of integration in order to be effective in the production environments, because I think we start from the container security. We discuss about the Snyk collaboration with Docker, then we have a Falco, then we have an open policy agent. But we have a Prometheus and Grafana as well. So these are other two different tools for the observability. Then we have the service meshes. So as you said, the cloud native ecosystem gives you the choices, because these are the learned experience from the past 20 or 40 years, that these are the things people need. So now we are building that tools that integrate easily with other tools in order to be everyone proficient.
Yeah, I mean, the integration piece, the integration piece is absolutely key to this, because, open standards and open source in general gives us the ability to plug these things together, right? And plugging them together is really where things start to get interesting. I mean, presenting all those different data sources through things like Prometheus. I mean, there are Snyk plugins for Prometheus as well, and those. It does give you lots of choice and lots of options about different ways of how to construct these things, providing we have open standards kind of underlying everything.
Yes, definitely. I think these are the really moving part, because container ecosystem is so many successful over the years, and it's evolved in a very small amount of time because of the great peoples like you, or you doing great amount of work in the container ecosystem, and people are looking for these tools, and somebody putting that effort, they are integrating that tool, and their tool is going to be the popular in front of the tools that they're integrating with is also popular in this small amount of time. But if we do that in isolation, I think we're never able to succeed in a very long run. So we are able to succeed in that cloud native landscapes because of the mutual collaboration and friendly environment in the cloud native ecosystem. And thank you, Matt. I think today's we have this time. So we wrap up our discussion. We start from the Docker CLI is Snyk collaboration. You can scan your images in the developer machine. Then the next piece is going on. You have some kind of container registry that is going to be secure. So Snyk has some collaboration with it. And you have also, when your containers are hosting the container registry, next two things you need to cater for is the open policy agent. The policies has to be understand how the policies are using in the production environment.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, container containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.